Alright guys, so in this video we will be discussing about load balancing and we will do a deep dive into it. Alright, so and I'm very much sure by this time if you're watching this video you might have already heard this term load balancing. So let's start with it. Okay, so let's start with what is load balancing, right? So load balancing is very crucial part in your distributed system. I don't know if you've heard of distributed system, because load balancing is the fundamental part of the distributed system, and I'll tell you quickly about the distributed system. So let's say you have your one server sitting somewhere around the globe and serving the traffic, right? But now your traffic is keep on increasing, but the server capacity now cannot handle that much of incoming traffic. In this case, what you will do is you will try to set up multiple components to your server, right? And try to add on few more CPUs, few more memory, or etc, all those things, and you will end up having a distributed system in place. So this is where the distributed systems comes in. Now let's say you already have multiple systems, right? Multiple servers. Now your traffic is coming into your system. How will you decide that where to reroute or which server will serve this particular traffic? So this is where the load balancing jumps in into the picture. All right, so load balancing, formally speaking, is a part of distributed system that does a distribution of traffic around the multiple servers. All right, so whatever the incoming request it receive, it's simply whatever the incoming traffic it receive, it's simply based on some algorithm, based on some calculation, it will reroute that request to a certain server, right? So you have multiple server, so it will distribute your request across one of the servers among your multiple servers. So that's the core responsibility of load balancing. All right, so before doing a deep dive into it, let's go back and try to understand that what is the world without load balancing, what are the challenges we have if we do not use load balancing, and what is the problem that load balancers comes in and solve, right? So let's go back and try to understand that problem. All right guys, so let's say you have your client, okay, and then you have your client. So these are your clients. So when I say client, that means let's say these are cell phones, right? The kind of application in your cell phone, Android or iOS, it could be anything. All right, so now you have one server, right, sitting somewhere, wherever you have set up your server, you have set a server set up. These requests are coming in directly to your server, so there is no load balance and nothing in between. Simple. These are clients. Now these clients are sending requests to your server, right? Now server is fulfilling these requests and sending a response back, right? Now let's say this, whatever is happening, it is happening for X amount of traffic. So X, let's say, understand it's a number, right? It could be anything, right? So let's say your X is between, let's say, 1K to, let's say, 5K. So based on your server capacity, this server is able to fulfill the request in between 1K to 5K in 1 hour, or let's say any metrics. Just assume any estimation. This is only for understanding. All right, so now understand your traffic, your incoming traffic, this increases, right? This increases to 10K to 50K, right? For this scenario, what happens is your CPU, this particular server, right, whatever you have right here, this server won't be able to serve all the traffic, right? Because this doesn't have that much of capacity in it, right? So now what you will do, a simple solution to that, what you will do, to these clients, you will simple add on few more servers to it. So let's say you have one server, you have now server 2, you have now server 3. All right, now let's say one server can handle 10K, one server can handle 10K, one server can handle 10K. assume any metrics, let's assume whatever you want to achieve, 50k or 40k or let's say 30k, right? Now this much you have added some more servers to your existing server, and all this setup is working in a way of cluster manner, right? So it's working in a cluster fashion. Now all these requests, so one way is, so this is your client. When I say client, that means mobile, kind of an Android application. So now earlier it was only one server, right? Earlier you already had one server, this one single server. So all the client can directly call this one server, because this server might have an IP, let's say 105.111.xxx, etc, etc. Now the clients are aware of the address at which your server is up and running, right? Now here, because of the fact you have added multiple servers, now a client needs to understand the other addresses for other servers as well, right? So let's say you keep list of 5 addresses here, 5 here, 5 here, and then 5 here, right? All the clients must be aware of all the address of all the servers. Now they will keep on calling this, or maybe this, right? But if you see, there will be a lot of chaos. There will be a lot. This whole entire thing, right? It's not organized. First, we don't know which server to call. Second, clients are strongly bounded with the number of servers. Let's say tomorrow, if I jump in and I add on one more server, then client needs to aware of another address, right? So your client implementation is dependent on your server, right? And your client has visibility what's going on your backend system. So all this system is very highly coupled, right? And the third and the worst thing of having this kind of architecture is, let's say all clients are keep on sending the server one request, right? And this server is overwhelming because all requests has been rerouted to server 1, because other clients doesn't know that the server 2 and server 3 has lesser load, so we can directly call the server 2 or server 3, right? Clients doesn't have this visibility. Now that's the another problem. So you will ending having a very bad performance of the overall software architecture. All right, so now what is the solution of it? The solution of it, that you simply, if you have this server 1 and if you have this server 2, server 3, and then server 4, and you have client 1, client 2, client 3, and client 4, client 5, so on and so forth. Now client doesn't need to understand about these servers, right? So we will introduce a layer of load balancer. This LB is the load balancer. Now all client will only know one address, the address of load balancer. All right, the responsibility of load balancer is to get this traffic, this incoming traffic, and distribute it among the different servers, right? Your client client will not have any visibility what is going right here, right? So in this case, in this case, your load balancer will be responsible for distributing the traffic here, here, and here, right? So now let's say case number 1, if you add on one more servers, does this part of the system will get affected? The answer is no, right? Now let's say you have 4 servers here. Will we end up having a very bad performance of software architecture? The answer is no, because you have load balancer. Load balancer knows which load balancer I have to reroute to request to, right? So I might reroute the request to the one who has the least load, least connections. I might reroute, or I will have a round robin fashion, right? I'll keep on sending one request to each server, but at some way I will manage the traffic in the correct manner, right? That's the beauty of load balancer. And the third thing is, your client is not strongly coupled. So client does not has to depend on your backend system, right? So all these aspects basically has gone away when you started using your load balancer. So this was, if you see, this was the bad practice of implementing architecture, and then we went on and then we understand, okay, this is where the load balancer comes in and saves our life, right? So this was the fundamental problem of load balancer, the problem load balancer solves. All right, so now let's move on to our slide and then understand the basic working of load balancing. All right. So I think if you see, right, in here I have already explained you, right, in the very rough diagram, I already have explained you how load balancer work, but still let's go back in PowerPoint and understand. I have already created a beautiful diagram. Let's try to understand this. So you see, here you have these clients, right? So these clients could be anything. Let's say if you have an application running in an Android operating system in your mobile, then it's a client, right? You may be using your application from a browser application. Could be anything, but it's a client. Whoever consuming your service is your client. So these are all incoming requests. You see all these arrows, and then you are calling to the address of load balancer. So let's say if you go to yahoo.com, yahoo.co.in, you might be ending up falling into the public IP of the load balancer that they have, right? Or maybe Apache traffic server. It could be anything, but the basic nature for whatever system they might have exposed using that public IP, it must be doing the load balancing. All right. So your load balancer will act as a first point of entry point for your overall system. So our clients are sending requests to load balancers. Now load balancer is receiving traffic. Now after receiving traffic, it is based on some algorithm. Now, as I said in my last diagram when I was drawing and explaining you, I explained algorithms could be anything, right? When load balancer is receiving a request, it may reroute your request to server 1. It may reroute your request to server 2. It may reroute your request to server 3. But your request will end up to server 2. How will this get decided? This will be decided using a load balancing algorithm. This is what is being used by load balancer. Okay, how to reroute the traffic, how to distribute the traffic, right? So load balancer does the distribution of traffic across the servers, but how to do it, this will be defined by load balancing algorithms. Okay. So now, and then using an algorithm, so let's say we are using round robin, right? So maybe let's say in round robin, one request will be forwarded to each server at a time. So let's say if there are 3 servers, n is equal to 3, so one server will receive 1 by n, 1 is equal to 3 overall traffic. All right. So now, based on the algorithm, it will forward the request to a particular server. So that's the basic functionality of load balancer, how it works. All right, now let's move on and try to understand the different types of load balancing. All right, so this is very important. If you see, I have already mentioned this round robin, and then I have already mentioned these least connections, and then weighted round robin and IP hash. However, there are multiple load balancing algorithms. I have only mentioned these ones, the popular ones. All right, so now let's go back to our notepad and try to understand that how these different type of algorithms works. All right, so now let's first talk about the round robin algorithm. Okay, so see, round robin algorithm is not something very specific to load balancer. If you have heard, I don't know if you are a person of computer science, you might have heard of operating system, right? In operating system as well, there are several algorithms. So round robin is basic algorithm, right? The way round robin works is, let's say you have server 1, you have server 2, and then you have server 3. Okay, now in this case, if you see, your n is equal to 3, you have 3 servers. So, and this is a load balancer. Now this is your client 1, client 2, client 3, client 4. It could be anything, right? Traffic can come from multiple clients. All these traffic is being going to load balancer. Now what load balancer does it, 1, 2, 3, 4, and then let's say 5, and then let's say 6. Okay, now for first request, your load balancer will send this first request to server 1. Okay, then second request it will send to server 2, third request it will reroute it to server 3. Now fourth request it will reroute it to server first. Now fifth request will reroute it to server second. Now sixth request will reroute it to server third. So that's the round robin fashion. Every time you receive a request, every time it will receive a request, it will reroute that particular request starting from server 1 till the server n. Alright, and it will keep on sending one request at a time to each server. So that's the round robin algorithm. Okay, so with n is equal to 3, so you see, so if n is equal to 3, so 1 by n is equal to, so let's say 1 by 3, so 1 by n traffic each server will receive. Okay, so there are six requests, six requests, every request will receive 1/6 part of it. Okay, so this was about the round robin algorithm. Alright, so now if you move on to now least connections algorithm, now tries to understand what is least connection algorithm. Okay, now least connection algorithm says you have again LB here, and then you have server 1 here, then you have server 2 here, then you have server 3 here. Okay, then you have multiple clients here, right? These are clients. Now let's say, let's forget about round robin for a moment. There are requests coming in, right? Now server 1, if I don't know if you are following up my videos, if in my previous video I explained the working of HTTP, there was a separate video of HTTP, that how HTTP works, and there I have also explained how TCP works, right? Because if you see, HTTP is layer 7 protocol, TCP is layer 4 protocol. HTTP works over TCP. Before sending out the HTTP call, those two different parties across the network creates a TCP connection first, right? So now let's say server 1 has the least connection. So let's say all these requests, all the amount of requests, the amount of server 1 request server 1 is serving currently is, let's say, only 20% of overall request, and let's say it is serving the 60% and this is serving the 40%, right? So now where do we have the least connections? Where do we have the least network connections in the any one of the server, right? So we have at the server 1. So whatever request comes in to my load balancer, it will reroute that request to server 1. Now let's say the connections capacity for server 1 has gone to 80%. Now we have server 3 which has 40%. Now it will start sending out those requests to your server 3, right? So wherever it will find the least number of network connections, it will rerouting all those requests to that particular server. So that's how your least connection algorithm works for load balancers. All right, now we have weighted round robin algorithm. So now let's go back and understand weighted round robin algorithm. Okay, so now again same setup. We have server 1, we have server 2, we have server 3, and here you have LB, and then here you have a lot of clients. Okay, now you have 3 different server machines. Now server 1 has higher capacity, it has higher capacity, right? The basic infrastructure resources to create server 1 are higher and stronger comparatively to server 2 and server 3, right? And then server 2 has higher infrastructure and stronger machine than server 3. All right, so now what I'll do, I'll simply assign some weight to all my servers, because if you see, my server 1 has more capacity to serve the traffic, and after server 1 my server 2 has more capacity to serve the traffic, and in the end my server 3 has least capacity to serve the traffic. So I will try to assign a weight according to the capacity of a server. So what I'll do, I'll assign 60% of the traffic to my server 1, since my server 1 is the strongest machine. And then I will assign, let's say, 25% weight to your server 2, and then I'll assign 50% to server 3. So that particular number you are assigning to each server, right, in this algorithm will be known as weight. It will be known as weight, W, right? It's a value for W. Now, based on the weight assigned to a server, your load balancer will keep on sending requests to that particular server. So now let's say your load balancer receives many requests. First, it will try to send all the requests, because 60% as weight is higher for as server 1. So it will keep on sending these requests to server 1, and then according to the weight it will send some requests to server 2 and then few requests to server 3. So that's how it will manage the traffic among all the server based on the weight assigned to all the servers, right? So this is weighted. This is weighted round robin. Alright, guys, so this is weighted round robin algorithm. Okay, so now in the end we have IP hash algorithm, and then this load balancing algorithm is interesting load balancing algorithm. So let's try to understand the IP hash. Okay, now understand the IP hash algorithm. Okay, and obviously it's the load balancing algorithm. Okay, now you have server 1, and then you have your server 2, and then you have your server 3, and then okay, so you have your server 1, server 2 and server 3. Then here you have your load balancer. All right, and then here you have the clients. Okay, now let's say you have in your mobile application, or let's say if somebody is using the browser application, you are trying to maintain a session. You are maintaining a session here, right? In that session you are sending out all the traffic between the server and the client. You're setting a password, setting a username, etc., etc., so on and so forth. Business logic could be anything. Now this all traffic will be sent to load balancer. Now this load balancer, whatever IP of this request, right, now based on the IP it will perform a hash function on that IP. So let's say IP1. Now hash on IP1, let's say outputs to, and eventually the output of hash will be a server node, right? So let's say a hash function when being applied to IP1 is end up to your server 3. So your IP1 will be rerouted to server 3. Now let's say the request 2 comes in with IP2. Now LB, your load balancer will do a hash function or IP2, and this IP2 ends up to a server node server 1. So let's say this will be your IP2, right? So the point is, whatever request it will receive, it will perform a hash function on the IP address, and whatever the server node is the outcome, it will reroute that particular request to the server node. Now where do we use such kind of algorithms, IP hash algorithms? Where do we need? I already told you, wherever we are using session. Why session? Because let's say for your IP1, your client is setting up a username and password within a session, right? And that particular request is being served by server 3. Now next time when server clicks or any event happens and the request goes to server 1, now here you see that the session was maintained in server 3, not was in server 1, right? Session for this client 1, IP1, was present in server 3, not in server 1. Now next time when the request comes in, it goes to server 1, but session doesn't exist in server 1. So that is incorrect, right? So this is where such kind of algorithm comes in, which supports this session, the stateful of load balancing. stateful nature of load balancing. So this is where it will perform a IP hash. So every time every time the same IP comes in, it will keep on rerouting it to the same server, right? Now there are certain problems with this kind of algorithms as well. Let's say because your hash function depends on the number of servers. So let's say if one of the server node goes down, if you add on new server, then your IP, the outcome of IP hash cannot be same. It may end up resulting to server 2, it may end up resulting to server 1. So that could be a false situation, right? Incorrect situation, inconsistent state you could reach to. So that's one thing, right? So now let's quickly move on to next topic. So we already covered all round robin, least connections, weighted round robin, and then we discussed about IP hash. All right. Now let's discuss about the types of load balancing. So in the types of load balancing, we have majorly two types. So there are one hardware load balancers, and then there are software load balancers. So load balancer done by hardware load balancing, and same applies for software. So hardware load balancer, I don't know if you have heard of in the old times, and today many company uses it, but because now you have cloud in place, so many companies have been migrated to cloud load balancers. But still, a lot of organizations are using hardware based load balancer. You have a kind of device, right? You buy that device and put it in your network. So that device is specifically designed or optimized to distribute traffic among servers, and it works at TCP UDP level, right? So it's very faster because it's specifically designed for network load balancing, right? So you get the fast distribution, but there are certain problems as well with hardware load. You cannot scale, right? You cannot have so many things, right? From the architectural perspective, you might end up having a lot of problems, but you still have a very fast load balancing mechanism in place whenever you're using hardware load balancers. And the point is, you use a hardware interface to implement that load balancing. For example, F5. Okay. Now you have software load balancers. So in software load balancers, I have maintained layer 4, right? And then I've said layer 7 load balancers. So layer 4 load balancers are the ones, I don't know if you are aware of OSI model, right? There are several layers in it. Layer 4 is the TCP UDP layer, and then layer 7 is the HTTP layer, right? The presentation layer. So the load balancers that works based on TCP UDP are the layer 4 load balancers, all right? And then the load balancers that works on your HTTP at the presentation layer are your layer 4 load balancers, all right? Then you have DNS load balancer. So you see, day in day out we are using .com, xyz.com, right, pqr.com, etc.com. So not only the website systems, right? Even if you see, if you are using Kubernetes, right? You have DNS everywhere in your cloud, in your everywhere. You can implement a DNS mechanism everywhere, right? Because you can simply, DNS is what? You are mapping a name with a particular address, right? So when you look up using that name for a particular address, you are again doing a load balancer. So those kind of DNS load balancer that are being used for load balance the DNS are the DNS load balancers. And nowadays you have certain special ones. For example, containerized load balance, the load balancers you are using in containerized environment. So if you are aware of Kubernetes, you might have heard of, right, the Kubernetes ingress, right? So you have many pods, and then before that pod, in your particular namespace, you have ingress controller where you define all the API rerouting. So when the first request goes to your, and the ingress will have a public IP address, all traffic will goes to your ingress controller, and from there it reroutes to that particular request to your particular pod wherever your microservice is running. So because we have containers now, so it's a world of Kubernetes, and that is where we have Kubernetes ingress. But again, the basic nature of ingress is also a load balancing nature, right? And then in the end you have service mesh. So this service mesh is service mesh is the architecture, and the way you implement service mesh using a framework or tool is the Istio. So you have Istio again, it creates a virtual service, and based on the virtual service it's implement the again the load balancing mechanism. So the point is you have load balancing everywhere. Wherever you go, we are being surrounded very much by the distributed system. Wherever you go, you will end up having a load balancers in place. All right. So now let's move on, and then move on to a topic: stateless and stateful load balancing. All right. So I have already prepared the stateless and the stateful load balancing this slide. So stateless load balancing. So if you see whatever we have discussed so far, right? If you go back to my design, and then you see, all right. So you see, so whatever we have discussed so far, if you go back, whatever we discussed this, right? We discussed this. Whatever we have discussed, this was all stateless, right? Except IP hash. Don't consider IP hash here. Whatever we discussed is stateless because it's not keeping track of any state, any session, any data. It's not keeping track of any state, right? It's stateless. So your request coming in, you have the servers. This is server 2. This is server 1, right? So your LB is just sending out request here, here, or here based on algorithm, right? And these servers are not keeping track of anything. Even in fact, this load balancer doesn't support any persisting any state for anything, right? So this was all stateless load balancing. It was not keeping track of anything. But now what happens when you need to keep track of certain session, certain things along with your server, along with your load balancer? So do we have any provision in load balancers so that I can afford to have sessions in my server, right, at a large scale? So let's understand that. So let's understand stateful load balancers. Okay. So now let's assume you have server 1 and then server 2 and then you have server 3. Okay. Before going there, understand there are two things I have mentioned, right? Source affinity, session affinity. Okay. So if you go back to the drawing part and understand that this algorithm, IP hash algorithm that I explained, is also known as the source affinity, because what your load balancer is doing, it currently consuming an IP address of the incoming request, mapping it to the server. So the next request, when the request comes in from the same client, because it will have the same IP address, again it will end up rerouting that particular request to the same server. So that's the support of load balancer is being done to support the stateful nature of the systems, because it is consuming every time an IP address for a request, it's rerouting it to the particular server, right? So if your session is being maintained at server 3 and if your IP1 is keep on coming from the client 1, it will keep on mapping the same request to your server 3. This whole concept, right, is known as your source IP affinity. All right, now let's understand the session affinity. Now what is session affinity? Now let's understand this is session affinity. Okay, so now let's say this is your client 1, so this is a browser application. Okay, and then let's say this is your client 2 and here you have your LB. Somebody logs in to your application, it sends a request to your load balancer. Okay, so that very first time your load balancer maps that request to your server 2. So this is R1, R1 goes here. Okay, now we will use some kind of identifier. Now let's say now this request 1 is fulfilled. Now second time when the request comes in, how will load balancer will know that I have to reroute that particular request to server 2 again, because server 1 is server 1 is the machine who is maintaining the session for C1, right? So let's say it is maintaining session for C1. Okay, now, and we are not using IP hash or source affinity or anything. The way of doing it is a load balancer, when sending out the response back to your client 1, your load balancer will send a kind of cookie parameter to in as part of the response, and will say server 2. So your cookie will have a value server 2, any key value pairing, understand, but there will be a cookie which will be sent as part of the response back to the client. Now client sends a request to, right? Now the moment client 1 will send the request to, it will send the cookie which is server 2. Now your load balancer will receive the request to and will see, okay, so it says server 2, so it will again reroute that particular request to server 2. So that's how you see your session is being maintained at server 2. So your all requests for client 1 will be rerouted to your server 2, and then same thing applies to C2 client, right? So it might save R5, and R5 goes to server 3, and the next time it will send cookie with it, and then it will say R6, it will send a cookie with it. Then the load balancer will understand I will have to reroute that particular request to here. So that's the concept of session affinity. That's how you are maintaining the concept of session affinity. You are using a kind of cookie or right, sending it as part of the response, and because of the fact the next time when client sends request, your load balancer will understand, okay, this particular request I have to reroute it to this particular server. So that's how your load balancer support the stateful nature of the systems, right, using your source IP and your session affinity. So right, so it was about this stateless and the stateful load balancing. All right, now let's move on to your high availability in the load balancer. So let's understand you have all the architecture in place, whatever architecture you have in place. Let's say this architecture in place. Okay, now here in this case, you see you have client, you have only a single load balancer in the architecture, and then you have servers running here. Now let's say if you see here, load balancer is the single point of failure. What happens if this particular load balancer goes down? Right, this is where your high availability comes in the picture and saves you. All right, so let's quickly understand the concept of high availability. All right, so now see, you have server 1, you have your server 2, and then server 3. You have your load balancer 1. So one setup, one way of implementing the high availability is you have your clients here. So these are your clients. Right, all requests are going from this load balancer 1. Now this is single point of failure, because if it goes down, everything goes down, everything will stop working. One way is you have another load balancer here, right, and the way you will implement is this load balancer will be an active load balancer, and this load balancer won't be using actively, so it will be called as passive load balancer. But let's say for some reasons this server goes down, this load balancer goes down, this passive will become the active load balancer. So all requests will now move on to this, and then it will start rerouting all the requests. So everything will be restored, right, and everything will start working. So that's the active configuration of implementing HA in load balancers. All right, so now let's understand another way. There is active, my bad. So this is active passive way of implementing HA. All right, now let's move on and understand the active. So it's very simple again. You have server 1, server 2, and server 3. you have your LB1, and then you have your LB2, and then you have your client 1, client 2, client 3, client 4, right? Active means both load balancers, because you have one load balancer as the single point of failure. So what you will do is you will maintain two load balancers together, actively working. So sometimes this client 1 sends request to this, and sometimes here, sometimes here, sometimes here, sometimes here. So that's the active setup of your HA, implementation of load balancers in the HA fashion, to implement the HA in the architectures. Right? It's very simple and straightforward. All right. So now let's move on to our last topic, which is state sharing in load balancers. Okay. Now understand what is state sharing in load balancers. Now one thing, go back and then understand that you have your server 1, you have your server 2, you have your server 3, you have your server 4, and here you have your LB, and here you have your clients. Okay. Now these clients are sending request to your load balancer. All right. Now, and then this load balancer is rerouting all this request. So one way, what will be the way? So you have currently 4 servers, right? And this is, let's say, order service. All these servers are serving a purpose for order service. Okay. Now what will happen if your server 2 stopped working and it goes down? What will happen, or suddenly your server 1 stops working and it goes down, right? So you need to understand the basic nature of this part. It's very dynamic. You might have server 3 sometime up and running, and then right after second movement you have server 3 goes down, right? So sometimes all the server nodes can up and running and can go down, right? So this is the dynamic nature of your backend system. Now, if you statically map all the servers in your load balancer configuration, right, what will happen in this very case? You now, let's say you have statically mentioned that you have 4 servers. Now your server 2 goes on for, let's say, any reason. Now if your request comes in and the load balancer maps that request to server 2, but you see server 2 has gone down already, so that request will be dropped, right? So that's where again we will fall into a very incorrect, inconsistent state. So better way of doing it is you will have a kind of service discovery here. All right. Each service will register itself with the service discovery, and their load balancer will pick all services from service discovery, or a correct name of this will be, I would say it will be registry, right? So the component in system design or in distributed system that maintains your service registry is the service discovery. You might have heard the term zookeeper, you might have heard the term console, right? All those things are service discovery. Whenever your services gets up, your services registers themselves in the service registry, and then your load balancer will keep on listening on the service registry. So let's say if your service 2 goes down, so it will deregister itself, that particular server will be deregistered from the service registry. So a load balancer will know this service 2 doesn't exist, right? It's part of the backend pool, so it won't be rerouting your request to the service 2. So that's the concept of state sharing in load balancers. The way you implement state sharing in load balancers is using service registry, right? That comes as part of the service discovery, which is console, zookeeper, and you have many others. If you can just go and Google around it on the internet. All right. So this was about all load balancings. We discussed about what is load balancing. We discussed about how load balancing works. We also discussed about multiple types of load balancing algorithm. We also discussed about load balancing types. Discussed about state less and stateful load balancing, and then the implementing high availability, and in the end state sharing in the load balances. So this video has gone little longer, but I wanted to explain thoroughly each and every concept, fundamentals of it, and we have covered almost everything, right? If you go through this video, you will understand the load balancer in depth, right? So now in the next video we will come with some other concept of distributed system. So this is kind of a distributed system series I have now started. All right, so in this video, this is what we had so far. Thank you so much, guys. We'll meet again in the next video.